Okay, so our next talk is by Christoph about, and actually I think it's the longest title, Challenges in herding. Oh, at least no screensaver. Herding a vast number of packages between the Debian and PostgreSQL ecosystems.
Okay, hello, welcome. So this talk is again about something that Andrew and Hilko and probably someone else has been talking about building packages in a structured way and getting it out to a number of users that are not directly inside Debian, but also but inside Debian and on the outside. So a few words about me. I've been DD since 2005. Shortly afterwards, started working at Creative, where I'm working as a PostgreSQL consultant, giving trainings, doing remote administration and stuff, and got involved also in PostgreSQL packaging in 2012. So it was quite a while later after I started working on database stuff, but have been the primary maintainer of Postgres and Debian ever since taking over from Martin Pitt back at the time. At the same time, I started working on a project on the Postgres side, which is this apt PostgreSQL org repository, which is hosting all the Postgres versions compiled for all the Debian and all the Ubuntu versions out there. So, and this talk is about connecting the Debian and the Postgres side of these two worlds. And luckily, my employer, Creative, is paying for most of the packaging work I'm doing in there. So that's quite nice. Okay, so first we start with Postgres on the Debian side. You all know this DDPO overview. There's at the moment 78 packages in the Postgres maintainer team. There's a few more related packages related to Postgres maintained by other teams, by other individuals, which I'm also looking at, but luckily there's a few more people working on that. To look at the packages, there's a few types. At first, there's the Postgres Server packages. Then we have this PostgreSQL common management layer on top or maybe below the server packages. Then we have a few Postgres application, which are mostly boring in this context here because they just have to be compiled once and then they are there. Libraries are, of course, a bit more interesting because they have more dependencies in all directions. And then what this talk is really about is how to get PostgreSQL Server modules or Postgres extensions, which is mostly the same thing, compiled for Postgres in Debian and in the other distributions. And this is really where the interesting part happens here. So the Postgres Server is a huge C program, which also has a huge built-in test suite, which is just invoked by make check world at build time. It has two major parts. The largest part, which has basically been there forever, is pgregress. I also have a short screenshot here, which is basically about executing lots of SQL queries on the server side and then checking if the result is what the developers are expecting. Next to that, there's a huge tab test suite. This is quite new, has been added about 2 years ago, or maybe 3, which is testing all the utilities around the server. In this example here, the PG-based backup tool is executed in several ways to check if the result is what is expected there. So all these tests are running at build time. So each time the server is compiled, that test suite is executed. The interesting part about packaging Postgres is that there's different Postgres major versions, and these are incompatible from a user viewpoint. So This means that Postgres extensions, C libraries, have to be compiled for each server version, and also the SQL feature set is a bit different, so users like to be able to choose which server version they install. So on the Debian side, we support installing several PG major versions in parallel, which means we create separate source packages. These are just called Postgres 9.6, Postgres 10, Postgres 12, and the upcoming Postgres 12, and so on. We just put all files into separate directories. So all directories have the version number in there. So these packages can be installed in parallel. What we do at the same time is that there's only one libpq5 package, which means the library packages produced by the server packages have the same name, so we're not supporting installing that in parallel in Debian. The nice thing about that scheme, it's not how Postgres is installing itself natively, but packaging it that way is supported by upstream. So I'm getting good support from upstream on that side. So if there's any problems in that area, they are willing to fix it. So it's not just something weird that Debian is doing. So on top of Postgres, Debian is putting a management layer, which is called PostgreSQL Common, which means it's a set of scripts that manage these set of multiple Postgres versions and instances per host on one machine. It's a set of Perl scripts which are pretty messy. They could be a bit shorter, but yeah, we're working on that. So if you've been using Postgres on Debian, you've seen these PG create cluster, PG ls clusters, PG something cluster tools. These are all added by Debian on top of Postgres. They are not part of the original Postgres distribution. PostgreSQL Common itself has a very large test suite with probably over 1,000 individual tests running on the Postgres server packages. And what it does is to test that in infrastructure, these PG cluster tools, and it also tests some aspects of the Postgres server. And the point where this is running is it's running using auto package test on the installed packages. So this is not running at build time, but it's running at install time. So this is one example for how it looks like. So it's executing PSQL in very various ways and to see if the interface to these different Postgres clusters on that machine works. So about building testing applications, often test suites are rare because it could be graphical applications which are hard to test. So what we're usually doing there is to do manual smoke tests, like build the package, start the program once, and if it runs, it's okay. We could be doing better in that regard, but yeah, if the application has a test suite, we like to use it, but often it's not that easy. So libraries are usually standard packaging packages. So if you have a library accessing Postgres in some way, just run the test suite at build time, try to make up something that runs as auto package on the installed packages, and we are mostly covering all libraries we are packaging there. So, as said, the interesting part is testing the PostgreSQL Server modules or extensions. As said before, the compiled modules are specific to the PostgreSQL Server version, so we have to compile each module once for each Postgres Server version that we support. So it means that the module packages need to be aware that there are several Postgres versions out there, or maybe there might be several versions out there. And the common practice, what we're doing in most packages, is there that we have one source package, like PostgreSQL foo, that will produce a set of binary packages where the $version part is the Postgres version targeted. So, of course, we are not manually updating all the packages for the list of Postgres versions that we have at the moment. So there's a packaging helper called PGBillText, which makes Debian control, Debian rules aware of the list of PG major versions that are supported. There's a small control file there that calls Debian PG versions, which lists the version that this package is able to support. In the usual case, it just says all, which means all Postgres versions could be used by that package, or you can put something like 9.5 plus in there to say that is the minimum Postgres version supported by this package. And what then happens is that we have a Debian control.in file, which I have on the next slide, where you can see that we have a template in there, which is just PG version, and then if you say PGBillText update control, it will generate the real Debian control file from that file at to be used really for building the package. At the same time, the Debian rules file is also using that PGBillText helper, which takes care of building, of looping over the installed Postgres versions to produce binaries for Postgres 10, 11, 12, and so on. So we have two rules here, the build rule and the install rule, and as you can see, the test rule here is empty. The problem there is that at the moment we can't test Postgres modules at build time, because to really test packages, we need to have the module installed in the server in user shell PostgreSQL, and that's it at the moment is or this is not possible at build time because we can't put stuff into user share. And unfortunately, at the moment, Postgres is not able to load modules from arbitrary files from the file system. So we have to defer the real PG regress run at build time to run at install time. And also a problem is that many make files out there are usually not safe for building out of tree. Usually we are creating separate build directories for each Postgres version, and many modules do not support that, but we have a workaround there where it just loops over. Instead of building for all versions and then installing for all versions, we have a loop that will do build, install, and so on, so until all versions are covered. So how do we actually run these tests? We have a wrapper script, pgvirtualenv, which is part of PostgreSQL Common, so you will probably have it already in your installation, or you have it in your Postgres installation if you ever installed Postgres on your machine. What it does is to create a throwaway Postgres instance and give you a shell to run commands in there. So you just say pgvirtualenv make install check, and it will run that command inside a shell environment where you have a temporary Postgres server that will be thrown away again at the end. So the test can do arbitrary things in there without destroying your actual data you might have on some Postgres installation on that system. So what you do in the usual instance for auto package tests would be just to loop over the supported Postgres major version and then run this make install check. A short version of that is pgBillText install check, which would just fire up a server for each Postgres version and then run the tests there. So in the most simple case, you have a Debian test control file where you say, I'm depending on this server dev all package, which is needed because it's containing the PGBillText tool. You say, I want to run this test called install check, and in this file, Debian test install check, you just say PGBillText, whatever option, install check. This is for simple cases where you just want to run one command per Postgres instance. If it's more complicated, or this is the simple case, how it looks like. PG virtual env will create a new Postgres cluster called 11 regress, and then do the usual steps for testing that package. In a more complicated case, you would say, I want to loop over all supported versions. You can say PGBillText supported versions. What this will do is to take the list of versions that the module package supports, like maybe all or maybe something like 9.5 and later, and will compute the intersection with what the system is supporting. Like if Debian is currently supporting PostgreSQL 11, but if you want to target more Postgres versions at that point, then PGBillText supported version will give you a list of versions that is supposed to be targeted here. Then you can write a for loop over it and then call whatever command inside in there. In that case, it says, give me a virtual env using that version, run some commands, and then the testing is done. Like here, this is the current example from testing the PG routing package, and actually I have at the moment a problem in there because the dependencies of that aren't yet quite right, but we'll get to that. It's a bit complicated in that area. Okay, this is the basic infrastructure we have for testing packages in the Debian packages. We recently started introducing Salsa CI pipelines for that. This is a screenshot from the beginning of the week. There were only 2 tests running on each package. I've added a third one in the meantime. We are not using the Salsa CI pipeline, but we should probably be looking into it, into merging it with that. What we are doing differently at the moment is that we are testing an unstable in parallel, which the Salsa pipeline does not yet do. And we need a different build step because we need this PGBillText update control step there to tell the package you should be targeting this and that list of Postgres versions in there. So the interface is as simple as the Salsa pipeline. There you just pointed at, you say just include this GitLab CI YAML file, which is stored in the PostgreSQL common package, and then it will automatically run the pipeline on that package. What I just did at DebCamp is to put this really into all packages and then fix the debris that accumulated there. There were about 10 or something packages to fix, mostly because of things that this build log hardening checker found, which probably before no one was looking at. So these were problems that we didn't have on the screen yet. What I also did yesterday is to trigger regular cron runs of these of all those tests. So even if there's not an upload or not a git push to the package, all packages will now be triggered once per month to see latent regressions. I was talking to the Salsa CI people about that before. I hacked it in a way that works now. We have to check if it's really a sane way to do that. But so far it looks promising. Yeah, and I should probably also be looking into adding the other tests that the Salsa CI team pipeline has in there, like PO parts and repro test. It's probably easy to merge it, but one step after the other. Okay, that was the Debian side of things. Now we move to the Postgres side of things, like where packages get built for all Debian and Ubuntu distributions supported there. So what we're doing there is we build, we take all packages from unstable, or really the Git version of the packages, and build them for, at the moment, 8 Debian and Ubuntu releases. That's from SID to Jessie. And the Ubuntu releases, notably the LTS ones. We do that for 3 architectures, AMD 64, i386, and some years ago we also added PowerPC. We do get regular requests to add more architectures, but so far no one has decided if we want to target ARM, ARM64, ARM something, and most importantly, who's sponsoring the build hardware for that. At the moment, it's 5 Postgres major versions that are supported. The oldest one is 9.4 at the moment, up to 11. And if you multiply these numbers, it means that each package gets compiled about 100 times. It's not exactly the product of these numbers, because we exclude some combinations, like the newer Ubuntu non-LTS releases are compiled on AMD 64 only, because I figured that no one is going to use Disco on 32-bit or something, but it's about 100 times. So, and of course, no one is going to try that these packages manually. So we need lots of tests to make sure that the packages are really working, because we basically everything we are building there is immediately shipped to users, and if something is broken there, we will break production systems of people out there. So this is all being triggered by Jenkins, which is yet another CI solution after the different ones we've seen earlier today. What we're doing there is creating a group of jobs for each source package. If you've seen Mika Prokop's Jenkins Debian clue, this is basically the same thing. I started using that, but ended up rewriting all scripts so much so that it's no a separate installation. So for each source package, we have a foo source package, which takes the Git input and builds source packages, but it doesn't do that only once. It does this for each distribution separately, which means, or which is needed because we want to add this version number suffix to all packages to make sure that users can upgrade from one version of the distribution to the next one. So this means each source package gets compiled or built at the moment 8 times. Then we have a foo binaries job, which takes these source packages and compiles them for the distribution and architecture required there. I can show you that screenshot here. It's a matrix job, which means that, which is a very nice feature in Jenkins, which is still missing in GitLab, which means you can give it a configuration and say, do this for this list of distributions and do this for this list of architectures, and it will automatically use the cross product of these. So this is a colorful but not so fortunate example. PG Loader is at the moment pretty broken. It just compiles on the newer AMD 64 distributions. It doesn't compile at all on the older distributions, and the yellow button here means it compiles but doesn't pass the tests. And it doesn't support PPC at all because it's a Lisp and we don't have a Lisp compiler for that. Okay, so it's a matrix job with these 2 axes. Jenkins is not restricted to 2 axes. You can add every more. This is a very nice feature there. And what's still missing is the list of PG major version, though the 3rd axis is handled inside the actual build, which using that PGBillText tool, which we've seen before. All of that is happening in sbuild on temporary change root environments, which is a very nice setup, which I can recommend to everyone trying that, which will give you very high performance build environments where you can do arbitrary stuff and then throw away again. So sbuild, change chroot, and actually overlay fs on tempfs is the combination there. That's very nice. So what we're also doing there is running auto package in the very same session, which means it's pretty fast because it reuses the same change root. The downside is that it still has the build dependencies installed, but it's really a setup that has proved to be working over the last time. Then for foo source and binaries, there's also called job foo, which is a Jenkins pipeline orchestrating the source, binaries, and a depot job to make sure the sources get built, the binaries get built, and depot is only called if everything worked. And next to these jobs, there's also a separate foo auto package test job, which is independent from the build pipeline. This job makes sure that the tests get re-triggered on all packages each month. So if there's latent problems in the repository, we will notice because at some point auto package tests will be rerun and we can see that something broke in between even without the package have been re-triggered. So that was the big overview. The details are of course a bit more complicated. We are using the same source for all distributions. So which we take the package as uploaded to unstable and rebuild it for all distributions with some version number attached. But sometimes the package in unstable doesn't work with the older distribution. So for example, the barman package has been moved to Python 3 recently, but Jesse and Trusty are still supporting Python 2 only, or it works only with that on that distribution. So we have a script called generate PGDG source, which adds so-called tweaks to the package. And in most cases, or in all cases, it's as simple as that. It's usually just a few set calls on Debian rules, Debian control. Usually it's just 1 or 2 lines. Yeah, it looks somewhat ugly, but it is a way to just get the job done. And it's not like we are doing pages of scripts there. It's just one of few tweaks to the package to say this build dependency isn't there on that machine. Usually it works quite well like that. To be honest, some packages in unstable are prepared in a way that this is easier to do than not. So like you can't, it's usually written in a way that deleting lines from the control file, like delete this build dependency, just fixes the package to be used on the older distribution. Okay, what else do we do there? We need some trickery on the repository side, which is using reprepro. The problem there is that we can't put several versions of one package into the same distribution. As mentioned earlier, we have several Postgres 9.6, Postgres 10, and so on source packages. All of them build a libpq5 package. We can't all put them into the main section of the archive. So what we do there is to move them to different components away. So we have separate archive components, just like non-free or so on. They are just called 9.6, 10, 11, and so on in the archive, where these extra packages get stowed away. Users usually don't need them anyway. So the libpq, ecpk, and so on library packages are cross-version compatible. And so far, I haven't seen any problems with doing that. So for more quality assurance, what we do is to run debcheck on the whole archive. Debcheck is a tool from the EDOS guys that takes a packages file and computes installability of all packages. So for each package, it will say this package can be installed in this repository given this other distributions, like is this package installable on Debian stable. And this is really interesting to see if everything in your repository can be installed on real-life systems. We run debcheck and build-debcheck, which is just the same thing for build dependencies. This is running every night, so we can, on the next morning, we can see what broke overnight. Usually problems spotted there are incomplete dependencies of packages that just got uploaded. Like the Python 2 problem I just showed with barman was spotted by this system because the barman package doesn't actually test installing the package. So this just means we have to add more tests to see the Python dependencies better there. It's sometimes real problems are spotted, but the auto package tests really catch most of them. So this is just adding another layer. But I can only recommend running that to everyone running a repository to really run debcheck on it. It's a really nice tool. Yeah. The output is in YAML format. It's sometimes a bit weird to read. It's a huge list of things that have problems. In that case, there was another Python problem there. That was one report from last week or so. But it was also a new package, which I could easily fix on the next day. Okay, so yeah, what do we do to get new packages into this repository? These are still lots of manual steps, so the emphasis is more on getting the tools right and not so much on automating everything. So what usually happens is that usecan spots a new upstream version, then I upload it to unstable, then I proceed to do it on the Postgres side, or if someone else maybe uploaded something, I didn't notice it. There's a script which calls what's newer in SID, which is a script to diff two sources files. Pretty simple thing, which just tells us which package is newer on one side or newer on the other side. Then we can trigger a new build in the Jenkins pipelines. And then we have an extra testing step there, which means packages uploaded are not directly shipped to users, but they are put into suites called SID, PGDG testing, or Buster and so testing and so on. And to get from testing to the live distribution, there's some, we call it promotion in between, which copies the file over to the suites that users are really using. And again, there's the same Perl script in there that just tells us which is the difference between the live and the testing distributions at that point. So yeah. So we have this axis, which means that everything gets compiled 100 times. It gets even more interesting if we want to get a new major release added to Debian. At the moment, Postgres 12 is in the beta testing phase, and we are testing that and also providing modules for users to build to, which means, yeah, we have to basically, on the Debian side, once this happens, we have to upload all packages again because we have to regenerate the Debian control file from debian-control.in, which is basically a sourceful bin NMU because no change in the package happens except for the list of binaries produced. And on the Postgres side, we have more Jenkins jobs there, which are called foo binaries beta, which then target this new Postgres version only. And the initial status when doing that was that only about half of the package actually worked with Postgres 12. 12 packages built, but the test failed. About 20 failed for some changes in header files and other stuff. And some couldn't be tested yet because they depend on a module that failed yet. So what I'm doing at the moment is to pester all people on GitHub to publish new versions to target Postgres 12. Of course, we are also running the auto package tests on all these new packages, which is especially important because, we are at Postgres 12 beta 1 at the moment. There will be more beta versions, and it is expected that a catalog version in the Postgres server will be happening for Postgres 12 beta 2, which means that we have to retest all binaries that we built before because it might not work anymore with the new server version. Okay. So as a future lookout, what's hurting at the moment? As said before, the most important thing I'd like to fix is to make sure that make install check could really be done at build time and not just at install time. It requires either patching the Postgres server and making do it or talking to upstream about properly supporting it. I have yet to decide which one I want to do. Then to really make packages work on all distributions at once, we need to target a debhelper version that is present everywhere, so we are still using debhelper 9 for everything. Then we have some internal problem that the builds for Jessie take 4 minutes longer than everything else. I have yet to figure out why that is the case. So even if some builds that just take a few seconds will take 4 minutes and a few seconds on Jessie. But luckily it's only a year to go until it's no longer in support. Maybe I just sit through it. Okay, the Jenkins setup is pretty complex. I'm not sure if anyone except me understands it. No, Michael has been working a bit with it, but it's probably something that I should be look into to reduce the complexity. Yeah, right. And then there's some other problems on the repository side, like what I would actually very much would like to have is that repro should allow several versions of the same package in one archive, which is important for users that want to downgrade to the second last versions or something. It's a patch there by Benjamin Drung. I have yet to try it. There are other repository software packages that could support it, like Apply, but I'd rather stick to something that is very field proven, and I think reprepo is still the correct tool to use there. Yeah, okay, that was about the stuff I wanted to talk about. So if there's any questions, I'll have to hear them.
Just two things addressing your pain points. We also use Jenkins, and we use the Jenkins job builder to automate all of the job building stuff. That helps a lot.
Yeah, we have that as well. Yeah, it's
okay.
600 jobs. You can't do them manually.
We also use the Jenkins glue, or we use it. You said you kind of re-implemented it afterwards, but that works very well for us. And we switched to aptly 4 years ago from RepRepo for the same reason, because we needed to be able to roll back to older versions. And aptly supported everything we needed except GPG verification, and we had that added by the author. So at least for us, it does everything we need.
Yeah, we are also using aptly for this Elephant Chat project Michael was talking about last year. I still don't get the whole command line. I still have to look at everything, and I think I better stick to something rock solid. But maybe we should move over. Yeah, could be.
It is also rock solid, but it has its own way of doing things.
Yeah, it has this giant pool of packages in somewhere in home something, and it's probably just too much. We need to be able to get rid of stuff there, because it will be several hundreds of gigabytes, and so like uploading a new round of PG minor releases is about adding 1 gigabyte of stuff to the repository, so it's growing pretty fast over time.
Yeah, we keep, I think, the last 10 versions of packages. So I might be able to provide you some housekeeping scripts if you
that would be
if you want to look into that.
Yeah.
Okay.
Any more questions?
So if I understood correctly, this PG virtual env creates a temporary Postgres instance with data directory in some temp, but it's totally visible in these PG LS clusters and all the stuff.
Yes. Well, to be precise, if you are running it as root, it will be visible. If not, it's created in some other directory where it's not visible.
Yeah, of course, because you need to be root to add to etc Postgres something.
Right.
Okay.
Yeah.
Cool. I didn't know that. I just checked that Postgres 12. It's not yet in experimental, so I guess it's only in apt Postgres.
It's in U for experimental.
Ah, okay.
So if you knew a FTP master to ask, just tell them to process it.
Okay, thanks.
So thank you. Since you mentioned the bus factor, how many people are in the Postgres team, or is it just you?
It's mostly me, Michael, Adrian, a colleague, Marco Nenciarini, Markus Wanner used to do stuff, but I haven't seen him for a year.
So 3.5.
Don't get all the credit people on the bus.
Yeah, we could use more people for looking at individual packages, and also more people for looking at the bulk of packages, which is mostly handled by me, to be honest.
Not good. Okay, thank you.
Hello, as you mentioned, merging with the GitLab pipeline provided by the Salsa team, I wanted to comment that there's a clear separation between the various task steps definition and their invocation. So it should be pretty easy to just import the definition and use the ones you're interested in, like RepRepo or things like that.
It's unclear if that works for testing and unstable.
Yes.
But I just have to try it. I haven't seen it. Haven't tried it yet. We were talking about that.
Any further questions? I also don't see any questions from IC, so let's thank Christoph again.